Hello everyone, welcome to Sinx Classes. In today's lecture, we are going to discuss problem number 8 and 9 of chapter 3rd and exercise 3.4 and that is part of our trigonometric function exercise. So we have already discussed quite a few problems, that is 3.2, 3.3, 3.4 exercise, and in 3.4 itself we have discussed a lot of problems here already. And generally when we start, we discuss about the theorem or the concept behind the problem, and then we start working with the problem. Alright, so in today's lecture we are going to discuss problem number 8 and as I mentioned. So whatever we require in these questions, we will first write those formulae and then start working with the problem. Alright, so this is my first problem, and to start with the first problem, I will just go back and remember my theorems. So if we have to find out, of course, the general solution of this. So we know that if sin x equals to sin y, then my general solution it becomes x equals to n pi plus minus 1 to the power n into y. When it is cos x equals to cos y, then it becomes x equals to 2n pi plus minus y. And when it is tan x equals to tan y, then my general solution becomes x equals to n pi, and this is plus 1. Alright, so this is my first, this is my second theorem, and this is my third theorem. Alright, so we are primarily going to make use of these. Alright, and even if you don't remember this formula, as I mentioned earlier as well, you can still work with the principal solution and look at the pattern, and then yourself you can write the general solution. So anyways, if you know that these formulae are derived using the observation of the general solution, of the principal solution, and that's how we will do it. Alright, so let's start with the first problem. So our first problem is saying sec square x sec plus 2x plus to 1 minus tan 2x. Alright, we also know a formula which is this, right, which is sec square theta minus tan square theta equals to 1. So when I see this sec square over here, I know that there is some formula to be applied, and then I'll make use of that formula. So what is my formula going to be? Sec square 2x would become 1 plus tan square 2x, right? Because sec square theta is equals to 1 plus tan square theta, because sec square theta minus tan square theta is 1, right? And this will become 1 minus tan 2x. I can cancel out 1 and bring tan 2x on the other side. So this will become tan square 2x plus tan of 2x equals to 0. And if I take tan 2x common from here, then again it will reduce to tan 2x plus 1, and this will reduce to a product of two numbers, 1 and 2, right? And we know that when such case arise, when product of two numbers or functions are 0, so individually one of them could be 0 or both of them simultaneously can be 0, right? So when such case arise, what we write? We write either tan 2x equals to 0 or tan of 2x plus 1 equals to 0. So when tan 2x is 0, we know that in such case, similarly we have this 2x, we can write tan 2x equals to tan of n pi. Just like sin theta, we know that whenever it's a multiple of pi, tan theta's value is 0. This implies 2x is equals to n pi. This implies x equals to n pi by 2 in first case. Look at the second one, wherein my tan 2x is equals to minus 1. Alright, now you got to look at where my tan theta would be negative. When you look at the coordinate system, you see first, second, third and fourth. You have tan theta negative in second quadrant and in fourth quadrant. It is positive in third as well as in first, right? So given this tan 2x equals to minus 1, we know that it has to be either in second quadrant or fourth quadrant. So what I can write here is tan 2x equals to, one of the values would be tan of pi minus pi by 4 or tan of 2 pi minus pi by 4. So what I've done over here is, I as well know this part as it, right? Tan of pi minus theta is minus of tan theta, and I as well know this tan of 2 pi minus theta is gonna be minus of tan theta. So this is gonna be my even multiple of pi, so tan will remain in tan, and then since pi minus theta is falling in second quadrant, so it will become negative, and this will become negative because it is falling in fourth quadrant. So right, so what we have got here is 2x equals to pi minus pi by 4 is 3 pi by 4, and then this is 4 to the 8 minus pi 7 pi by 4, right? So given this, I can write 2x equals to, my general solution will be n pi plus 3 pi by 4, right? Given this, I can write x equals to n pi by 2 plus 3 pi by 4 or 3 pi by 8, because 2 will go and divide, so 4 into 2 will be 8. So with these two, what we have got is x equals to n pi by 2, and what you have got here is, the second solution is x equals to n pi by 2 and plus 3 pi by 8, right? So we have to put it or, so either this is true or this is true, alright? So this is what would be your general solution. Okay, so let's move on to the next problem. So my next problem has got sin x plus sin 3x plus sin 5x equals to 0. So looking at this, I again realize that I may have to make use of formula sin c plus sin d, right? And if you don't know the formula, we'll just try to remember it. So my sin c plus sin d would be what? 2 of sin c plus d by 2 into cos of c minus d by 2, alright? Now, we know that this is sin c plus d, but which one to take, right? It's a question, right? And when you look at again closely, when you look at this, when you put c equals to x and d equals to 5x, then your c plus d by 2 will become what? 3x, right? And this is what is available here as well. So instead of putting sin x plus sin 3x together, I might want to put these two together. Why? Because I am looking at sin c plus d by 2 becoming sin 3x, and I might be able to take that common, right? And as you know, what we are trying to do to this expression is, we want to make it as a product of two functions, we could call it, and then we will equate each of them separately to 0. P1 equals to 0 and P2 equals to 0, alright? So let's do that. So we'll put sin x plus sin 5x together, and then we'll keep sin 3x separately, and then this is equal to 0. Now sin c plus sin d, we'll put 2 into sin of c plus d by 2 into cos of c minus d by 2, alright? And then my sin 3x remains as this, sin 3x is sin 3x. Now simplify this, x plus 5x by 2, this will become 6x by 2, and that will become what? 6x by 2 will become what? 3x, right? So now my 2 of sin of 3x into x minus 5x will become minus 4x, and minus 4x by 2 will be minus 2x. So cos of minus 2x plus sin of 3x equals to 0. Now I can take sin 3x common, right? So I'll take sin 3x as common, and now again my expression is like 2 of cos. Now we also know that cos of minus theta is equals to cos theta, right? So we'll use this formula. So cos of minus 2x will be cos of 2x simply, and then here when I take it sin 3x common, so 1 remains, so this is 0, right? Now this implies either sin 3x is 0 or my 2 cos 2x, my 2 cos 2x plus 1 equals to 0. These two cases arise, and when this is the case, we know that 3x is equals to n pi. Directly I can write, I have been doing it, so I am just writing because I could have written sin 3x equals to sin 3x equals to sin n pi, and then equated 3x equals to n pi. But I'm just doing in one step. So x equals to n pi by 3 in one of these cases. In the other case, we have got 2 cos 2x plus 1 equals to 0. This means 2 cos 2x equals to minus 1. This means cos of 2x equals to minus 1 by 2. Alright. Now we know that cos theta is negative in which quadrant? In second and third quadrant, my cos theta is negative, right? So again, just to get the value, what I will do is, I can write cos of 2x equals to cos of pi minus pi by 3, and then the second one will be cos of pi plus pi by 3. Both the cases, basically cos of pi plus theta is equals to minus cos theta, and cos of pi minus theta is also minus cos theta, right? You know that? So, given this, cos of 2x equals to, first one is cos of 3 pi minus pi by 3 will be cos 2 pi by 3, right? Or cos of 3 pi plus pi by 3 is 4 pi by 3, alright? Given this, we can write the general solution as 2x is equals to 2n pi plus minus 2 pi by 3, right? Given this, we can as well write x equals to n pi plus minus pi by 3, alright? Because I'm just dividing it by 2 altogether, so 2 cancels out, so I will be left with this. Now, with both of these together, I can write x equals to n pi by 3 or x equals to n pi plus minus pi by 3, and don't forget to write where n is element of z. I might have missed in the other one as well, which you should not be doing. You should write this n is element of z. It means that n can take values negative, positive, 0, all that. And in either case, we know that since you move in this circle, you move in this direction or this direction, right? You will be able to get the same value. So that's why we put it as n is element of z. With these two questions, we are done with exercise 3.4, right? Now we will be doing miscellaneous exercise in the next video. Thank you for watching this video. If you have any questions, please ask me in the comment section below. Have a nice day.